All right, so this video is a little bit extra on Lewis dot diagrams, and it deals with what do you do if your compound has an overall charge. All right, and so we will look at two of those. And basically the one extra step is that when dealing with a compound that has an overall charge, right, most notably like polyatomic ions, then you have to add or remove electrons, right, sometimes, but not always, from the central atom to account for this charge. So, all right, my example would be when drawing the dot diagram for something like carbonate, which has a -2 charge, right, 2 electrons are going to need to be added because that -2 means it has 2 extra electrons. One of the things that's going to be important to know for this is calculating formal charge. All right, and so the formula for calculating formal charge is pretty simple. You just take the number of valence electrons that the atom has, you subtract from it the number of lone pairs that are around it, and then subtract from that half of the bonding electrons, right? So fairly simple, valence electrons minus lone pair electrons minus half the bonding electrons. So the rules, there are a couple extra rules for this. So elements cannot exceed a full octet unless they are a center and they're hypervalent. So hopefully you remember hypervalent from the last video. Formal charges on individual atoms must be kept as low as possible, right? So example, you can't give one oxygen in a compound a formal charge of -2 when there are 2 other oxygens with a formal charge of 0. That just doesn't work. Formal charges on atoms should align with their ionic charge when possible. Right, for example, you should not have boron with a -1 formal charge and nitrogen with a +1 formal charge in the same molecule, because that is not the ionic charge that each of them really wants. And then the sum of all your formal charges in the molecule has to be equal to the overall charge. Right? So this is also true for molecules that don't have an overall charge. It just means that in those molecules, the sum of the formal charges of the atoms will be 0. So let's get right into an example. For this particular one, we are going to look at ammonium, which, if you don't have your polyatomic ion sheet right in front of you, is NH4 with a +1 charge. Okay, so it's going to start out exactly the same. We're going to write down the element symbols and fill in dots for valence electrons. All right, so hydrogen, column 1A, it's got 1 valence electron. Nitrogen, column 5A, it's got 5 valence electrons. Great. Central atom. All right, again, hydrogen's there. It's never going to be the center. The only other element is nitrogen, and so nitrogen's going to be the center. So we're going to, again, arrange the outer atoms around the central one and draw in the single bond. So nitrogen, right, we've got our 4 hydrogens. We're going to draw single bonds between them. Right, remember the bond is 1 electron from hydrogen, 1 from nitrogen. So we've used up 4 electrons from nitrogen. We need 1 more. We've got our 5 electrons, or our 4 hydrogens, each with 1 electron. We've used up those electrons. Okay, now we're going to add or remove electrons from the central or other atoms as needed to agree with the charge. All right, so if we look at formal charges right now, right, to figure out where we're going to need, so for hydrogen, right, valence electrons, it's got 1 valence electron, it has no lone pair electrons, and then in a bond there's 2, so 2 electrons divided by 2, it's going to equal 0, right? So formal charge, it equals 0. Nitrogen right now, 5 valence electrons, right? We've got 1 electron that's not in a bond, right? And we've got 8 electrons divided by 2, all right, because there's 4 bonds, 8 electrons, which would be 5 minus 1 minus 4, which is 0. When you add those up, they do not add up to 1, right? Plus, if we look, we have a problem here, right? There's 4 bonds, which is 8 electrons, plus 1 electron, making 9. Nitrogen is not hypervalent. You cannot have this as a situation, on top of the fact that you should never have 1 electron hanging out on its own. That's a radical. We don't want that. So we have to remove an electron. So we remove that electron from around nitrogen, and we can recalculate the formal charge around nitrogen. So now we've got 0 lone pair electrons. We've still got our 8 bonding electrons, which makes 4. So 5 minus 0 minus 4 is positive 1. Which when you add these up, plus 1, right? The overall formal charge agrees with the charge of the ion. Great. That is the Lewis dot diagram for ammonium. We did that. We did that. Okay, a diagram of a negative. So let's draw a big line on the paper, or not the paper. So let's do carbonate, right? If this thing will cooperate. So carbonate, right? CO3 minus 2. So first, elements and symbols, C and O. Carbon, 4A, 4 valence electrons. Oxygen, 6 valence electrons. Great. Ooh. Central atom, right? Furthest from fluorine, which is carbon. Carbon is also carbon, so it's going to be the center. Great. Arrange atoms. So we need to arrange the atoms. We've got carbon, we've got oxygen, 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 right? We draw 1 bond between each of them. Plus we've got an electron there. We've got these looking like this. And this is all kinds of bad, right? Each one has a single electron somewhere that's not paired. That's really bad. Right? So if we look at formal charge at this point, it's not going to be good, right? I mean, technically it will be because, everything's going to be 0, but that's not going to get us where we want. We need 2 more electrons. If we try to put those electrons on carbon, right, we're going to have a problem because we've got 2, let me back up. We've got 3 bonds, which makes 6 electrons. We've got this pair over here, which makes 8, and then 9 electrons over here. Carbon not being hypervalent, that's bad news. So basically, what we're going to have to do is we're going to have to move these extra electrons off onto the oxygens, right? Which is great. So there we go. Now carbon, right, is not having too many electrons. So there we go. Next step, full octet. So if we're looking, right, each of these oxygens, 2, 4, 6, 8, all right, so this oxygen, they're all set. Carbon though, we've got 3 bonds, so that's 6 plus 7, not good. This oxygen, 1 bond plus these other 5, right? 7, not good. So now, right, we're going to draw some multiple bonds. So just like we did before, we're going to take electrons from either side here. We're going to draw a bond. Now, if we look, I will clear up these numbers here. All right, so not getting confused. So now if we look, right, both of these, carbon, 4 bonds, which means 8 electrons, great. Oxygen, 2 bonds, 2 lone pairs, 8 electrons, fantastic. Now we look at formal charge. All right, so I'll label these oxygens 1, 2, 3, and we've got carbon. So for oxygens 1 and 2, right, they have 6 valence electrons, they have 6 lone pair electrons, right, and they've got 2 bonding electrons, which makes for -1. All right, we've got 2 of those, so times 2. We've got oxygen 3, which 6 valence electrons, 4 lone pairs, 4 bonding, 0. Carbon, 4 valence electrons, 0 lone pairs, 8 bonding electrons, 0. Right? Which is great, because we've got 2 atoms with -1, which makes overall -2. Everything checks out. All right, that's it. That's all I got for this. That's all there is. Now, go practice.